Good evening, everybody. Now we are taking up the types of flow. In that, first one is steady flow and unsteady flow. Let me take up first the steady flow. In the case of steady flow, it is always with respect to time. Whatever the flow characteristic that you are measuring, be it velocity, be it depth, especially in open channel flow, kindly remember it is the depth of flow is very, very, very important, right? Whether it is velocity or depth of flow, they should not change with the time at a point. At a point, the flow characteristics such as velocity or depth of flow should not change with the time. So, how to represent mathematically? We can represent dou v by dou t is equal to 0, dou y by dou t is equal to 0. This is very, very, very important. So, what I can write, the depth of flow does not change with the time at a point. This is what we call it as basically the steady flow. That means the depth of flow is independent of time, is independent of time. Right? This, if we remember enough, most of our study is steady flow. Most of our study, not study, is steady flow. Then what is unsteady? In the case of unsteady flow, the flow characteristics such as velocity or depth of flow changes with the time. They change with the time. Depth of flow changes with the time. Right? Depth of flow is dependent on time. So this study we are not carrying out here. Then we go into the second point, that is uniform flow and non-uniform flow. If you remember the part 1, part 2, what I mentioned to you is part 1 is uniform flow, part 2 is non-uniform flow. That means we are studying both the things. This is with respect to space. This is also called as with respect to length of channel, right? With respect to distance. The flow characteristics do not change over a given length of channel. That means dou v by dou s is equal to 0. But most important thing is dou y by dou s is equal to 0. That means the depth of flow does not change over a given length of channel. over a given length of channel. Depth of flow does not change over a given length of channel at a time, right? So this is what we were studying. So remember, depth of flow is constant. That is what uniform flow is throughout, right? That is what most of our study is. Then what is non-uniform? This is also we are studying non-uniform flow. That means dou V by dou S is not equal to 0 or dou Y by dou S is not equal to 0. That means the depth of flow changes over a given length of channel. If that is the case, we call it as non-uniform flow. This is also we are studying. So what is this actually? We have again the non-uniform flow is classified under two things. One is gradually varied flow, and second one is rapidly varied flow. This is GVF or PF. First, what is non-uniform flow? Depth is not constant. Depth of flow is not constant. Depth of flow varies. This is non-uniform flow. How these depth variations are? If the depth variations, if the depth of flow changes gradually, increase or decrease, whatever it is, over the given length of channel, over the given length of channel, we call it as gradually varied flow. If the depth of flow changes rapidly, suddenly over a given length of channel, again here the depth of flow changes. Depth of flow changes are high. That means if the depth of flow initially may be, for example, 5 centimeters, suddenly the depth of flow may change to 3 meters. For from 5 centimeters to 3 meters, or 10 centimeters to 2 meters, or 15 centimeters to 1 meter. So that means sudden change in depth of flow in the channel. That is what we call it as so number one is rapidly depth changing, whereas here suddenly the depth is changing, and the changes are also depth of flow changes are also high or large, whatever it is, then we call it as a rapidly varied flow. So what we mentioned in the uniform flow, the uniform flow means the depth of flow does not change over a given length of channel. Then what is non-uniform flow? Depth of flow changes over a given length of channel. That changes in depth of flow is small, is gradual, then we call gradually varied flow. And whereas this depth of flow changes are sudden, large, we call it as rapidly varied flow. The example for gradually varied flow is only flow in channels, non-uniform flow in channels, right? Whereas rapidly varied flow example is hydraulic jump, hydraulic drop. So these are the change. So this is the second point. Then we go into the third point. For us, the third point is basically laminar flow and turbulent flow. We already studied that the flow, whether it is laminar or turbulent, is basically based on Reynolds number. Reynolds number is the thing which classify whether the flow is laminar or turbulent. And the general equation is rho VL by mu or VL by nu. This is the general. For pipe flow, we have just now completed pipe flow chapter. For pipe flow, this characteristic length L, we have written it as rho Vd by mu or Vd by nu. That's how. But for open channel flow, which is now we are studying, Reynolds number is equal to definition is the same. It is inertia force by viscous force, and the general equation is rho VL by mu or VL by nu. But now the characteristic length L in open channel flow is R. This R is equal to hydraulic radius or hydraulic mean depth. So if I replace it, Re is equal to rho VR by mu or VR by. Now the question is, what is R? R is already I mentioned hydraulic radius or hydraulic radius or hydraulic mean depth is equal to wetted area of the channel by wetted perimeter. Wetted area of the channel, it is equal to wetted area by wetted perimeter. Please remember R is equal to A by B actually. Now, depending upon the shape of the channel, for example, the channel shape is rectangular. Then naturally, if this is B and this is Y, then naturally this is free surface. A is equal to By, right? P is equal to B plus Y because this is Y, this is B, this is Y. So it is total is B plus 2Y. So therefore R is equal to By by B plus 2Y. Like that we have to calculate depending upon the shape of the channel, we have to calculate and substitute for R. So finally, what are the limits actually for laminar flow in open channel flow? In open channels, Reynolds number should be less than 500. Whereas for pipe flow, it is less than 2000. Whereas for open channel flow, it is less than 500. And turbulent flow in open channels RE is greater than 2000. So please remember these values. For there, actually in pipe flow, first one is 2000, second one is 4000. But here, this is the thing. In between these two is what we call it as transition. That means 500 to 2000. So this is the third one. Fourth one is we are not so interested about laminar flow and turbulent flow in open channels. Only for the sake of types of flows I have given. Otherwise, that is not so important. But what is important in flow open channels is the last one. In the open channels, 1 and 3 are not so important because the one is already always we study about steady flow only. Only remember with respect to time. Third is only remember what is Reynolds number, what are the values. But the most important things in open channel flow is number two, uniform flow, non-uniform flow, and last one, subcritical, supercritical, and critical flow. This is very, very important. Again, we will study this as a complete topic actually. But before that, so this is basically how to define it. Kindly remember which is the dominant force in open channels is gravity force. This is the force which is dominant because the slope of the channel is the mainly responsible. So gravity force is predominant in open channels. So here in open gravity force, you know the what is the dimensionless parameter which takes care of gravity force? That is nothing but Froude number. That is why Froude number is used for classifying the flow as subcritical, critical, or supercritical. So Froude number, which is equal to Fr, is equal to square root of inertia force by gravity force, which you are already learned in basically the modal analysis, if you remember. So, but now what is Froude number? You we have done it. It is basically V by it is we have done it as V by root GL. That's how we have done it. Is general. And if I apply it for open channel, Froude number is equal to V by root GD. This is for open channels. That means the characteristic length is this L is equal to D basically. And what is D? D is hydraulic depth. And D is equal to A by T. A is equal to wetted area. T is equal to top width. So if you take it a rectangular channel, right? Now this is bottom width is B, this is Y. Then naturally top width T is also equal to B. So therefore, if you calculate D is equal to A by T, By divided by B, it is Y. So in the case of in the case of rectangular channels, D is equal to Y. For other shapes, we can find, right? If now, what is subcritical? Subcritical flow means this V by root GD Froude number is less than 1. Critical flow means this Froude number V by root GD is equal to 1. And supercritical flow means Raoult number V by root GD greater than 1. This is very, very, very important actually. So if you remember up to this, in the next class, we will see how to take it up. That in future also we talk more about the uniform flow, and we also talk about the basically uh, critical, subcritical, and supercritical flow. Right? We stop the lecture here.
Like, share, and subscribe. Hit the bell icon for more updates.